Today we're going to be talking about something called parametric equations. So let's go ahead and define parametric equation. Parametric equations gives an x and a y location or a position based on time t or just the variable t, which is called the parameter. So these work a little bit differently than what you're used to with functions, where you input an x and you get out a y. Here, the independent variable, we're going to be plugging in various values of t. As a result, we'll get different x values and y values. So let's look at an example. Okay, so we're going to sketch the curve given by the parametric equations over the given interval. So our parametric equations, this is how they look like. You have an x equation in terms of t and a y equation in terms of t. So we have x equals t squared minus 1, and y equals t over 4, or 1/4 t plus 2, and our given interval. I'm going to make a note here. For questions like this on your homework, they're going to give you a very big window on your homework. Just do -2 to 2. You don't need to do like -7 or whatever they're telling you to do. So anytime we're graphing something new, plugging in points is the way to handle this. So what I'm going to do here is I'm going to create a chart with 3 columns. We're going to have a t, an x, and a y. So my t's are going to go from -3 to 3. And then we're going to plug those values into each of the 2 equations. Okay, so we're going to plug these into our x equation. So -3 squared minus 1 is 8. -2 squared minus 1 is 3. -1 squared minus 1 is 0. 0 minus 1 is -1. Back at 0. 3, and 8. For the y values, if we plug these in, you're going to have a -3/4 plus 2 is 1.25. Plug in 2, so -1/2 plus 2 is 1.5, 1.75. Plug in 0 to get 2. Plug in 1 to get 2.25. Plug in 2, we'll get 2.5, and 3 will be 2.75. Okay, now we're going to graph. On the graph, we're just going to graph the x and y coordinates like we always have. The t we won't actually see on the graph, but we'll have a way of dealing with that when we do it. So we're going to go ahead and graph. If you're drawing your own graph, make sure that your x's go from a minimum of -1 out to a maximum of 8, and then your y's, you don't need too big of a range because we're going from 1.25 to 2.75. All right, so we're plotting these points just like you normally would. So we'd go to an x value of, and actually I'm going to alter my y-axis. On my y-axis, we'll make this 1, make this 2, make this 3, because we've got kind of small values of x. So we're going to go out to 8. 1, 2, 3, 4, 5, 6, 7, 8 in the x direction, and we're going to get 1.25. We're going to have an x value of 3 and a y value of 1.5. An x value of 0 and a y value of 1.75. An x value of -1 and a y value of 2. Then we're at 0, 2.25, 3 again at 2.5, and 8 again at 2.75. Okay, so if I connect these dots, we end up with a parabola. Now I said we're not going to be able to see time. We don't know where time was 0 or time was -3. So what we do to this graph is add a direction to it. So we started at this point, and then as we plotted our points, we were going this direction. So I'm just going to indicate that with some arrows, that my points were being plotted that direction. Okay, now I'm going to show you how to convert from this new parametric form to our old-fashioned rectangular form with just x's and y's. First step is to solve for t in both of the x and y equations. Once you have them both solved for t, you'll set the two equations equal to each other. And lastly, we will solve for y if possible. All right, so we're going to write this parametric equations into rectangular form. So I'm going to take each of the equations and solve for t. So here I'm going to subtract 2. And then we're going to take the square root, but when we take the square root, it's going to be plus or minus. Okay, for this one, I'm going to divide by 2 equals t. Now that I have those two equations equal to t, I'm going to set them equal to each other. So plus or minus square root of x minus 2 is going to equal y over 2. So then I'll just multiply by 2, and that will be my y. So y is going to be plus or minus 2 root x minus 2. So this wouldn't be a function, it would be a sideways parabola like the one we previously graphed, but in parametric that is a possibility. Next we're going to look at equations that have sine and cosine. So converting to rectangular if the parametric equations have a sine and cosine. What we're going to use is our good old favorite sine squared theta plus cosine squared theta equals 1. So let's look at an example. Okay, so we're going to write in rectangular form, and then we're going to graph the parametric equations x equals 3 cosine theta and y equals 5 sine theta. So first we're going to be plugging this into sine squared theta plus cosine squared theta equals 1. So I'm going to solve for sine squared and solve for cosine squared. So here I'm going to divide by 3 is cosine. Then I'm going to square it. So x squared over 9 equals cosine squared. Here I'm going to divide by 5 and then square it. Okay, and then we'll replace these two for the sine and the cosine. So we're going to have y squared over 25 plus x squared over 9 equals 1. Well, this, what type of graph is this? This is an ellipse. So that's how we're going to graph this. Remembering back to algebra 2 with your minor axes, major axes, all that. So y, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 1, 2, 3. So remember the length of the axes is the square root of the denominator. So in the y, we're going up 5 and down 5. And then in the x, we're going 3 and negative 3. So we get our ellipse. We still want to indicate direction. And how we can do that is go back to our original equations, and I'm going to plug in two simple values of theta. I'm going to plug in 0, and I'm going to plug in pi over 2. So if I plug in 0, cosine of 0 is 1, so I'm at the point 3, sine of 0 is 0. If I plug in pi over 2, cosine of pi over 2 is 0, sine of pi over 2 is 1, so I get 5. So the order these were graphed in is this point followed by this point. So my direction is going to go this way. So I'm going to show you how we can graph parametric on the calculator, and we can see the direction and all of that. So I'm going to do the ones that we've already graphed, and then I'm going to introduce you to a new one. So the first one we're going to graph is going to be the first one we graphed by hand, t squared minus 1, t over 4. All right, we're going to take our calculator, we're going to go to mode. Okay, down here below radian and degrees it says function. You have been living your whole lives in function mode, but there are other modes that we can be in. So we're going to go down and we're going to select parametric. In our next unit, we're going to do this in polar. Okay, then I'm going to go to y equals. And when we go to y equals, it's no longer y equals. It's x1t equals and y1t equals. So these are our parametric equations. So I'm going to plot in t squared minus 1. Well, where do you get a t, you ask? This variable button that you've been using without paying attention to all these other letters on it, x, t, theta, n, when you push that button, you're going to get a t. So we're going to do t squared minus 1 for my x. For my y, t over 4 should have been plus 2. Okay, so we enter that in. The next thing we're going to do is adjust the window. So go to window, and this has changed as well. So not just x-min, y-min, all that, you now have a t to deal with. So I'm going to go from t-min to t-max just from -10 to 10. The step, the smaller you make this, the better your graph, but the slower it will graph. So 0.1. For my x, min, and max, I'm going to go from -5 to 30. For my y's, I'm going to go from -1 to 5. And these are things you could play around with. But let's look at our graph specifically paying attention to the direction. Okay, so there's that parabola that we graphed by hand, and noticed it went this direction. All right, so now let's graph that ellipse. So we have that should be x equals 3 cosine theta, and y equals 5 sine theta. So I'm going to go to my y equals, clear these guys out. I'm going to have a 3 cosine theta. It's going to be t in the calculator, and then 5 sine t, because I mean there is a theta here, but for parametric our variable in the calculator must be t. For my window, depending on if you're in radians or degrees, if you're in radians like I am, I'm going to go from 0 to 2 pi. If your calculator is in degrees, you want to go from 0 to 360. T step then, if I'm doing this, I'm going to go 0.01. For my other ones, I'm just going to go from -10 to 10 in both the x direction and the y direction. And we're going to graph. So I made a small t, so it's graphing pretty slow. Now it kind of looks like a circle. But if I do a zoom square, it'll adjust the aspect ratio so that it'll actually look like what it's supposed to look like. And there's our ellipse. Next, I want you to try graphing this one on your own. So graph x equals cosine 3t, y equals sine 2t. For your window from 0 to 2 pi if you're in radians, from 0 to 360 if you're in degrees. A step of 0.1 is fine, and then negative 2 to 2 in the x and negative 2 to 2 in the y. So I want you to graph that and see what happens. Alright, so when you graph it, you get something that looks like that. So we can create some really cool graphs with parametric because we have a lot less restrictions than we do in functions. Okay, next we're going to talk about lines. And we're going to talk about a couple of different equations for lines that are going to be new to you. We're going to talk about a vector equation of a line and parametric equations of lines. Okay, so let's say I have some line here. We need two things in order to graph a line or to write the equation of a line. We need to know its location or point, and we need to know its slope. So I'm going to say I've got some point here, x1, y1. So I know the line has to go through there, and then we want it to go at a certain angle. Well, we're going to think about this a little bit different than slope. We'll tie it back to slope, but we're going to do it as a vector, because a vector gives us a direction. I'm going to call this A1, A2. This vector is called a direction vector. But I said we tie this back to slope. Well, we know slope is the change in y over the change in x, okay, rise over run. Well, the change in y given to us in the direction vector is going to be the y coordinate there, or A2. The change in x is going to be given to us by this x coordinate, A1. Next, we're going to talk about the vector equation of a line. So we need the point and the direction vector. So we're going to go through some point, x1, y1, with a direction vector a1, a2, or it might say parallel to vector a1, a2. So this, don't worry too much about this notation, but it's just something used in vectors, is going to equal the point plus t times the direction vector. Okay, we won't use these too often, but essentially, if you wanted to generate points, you'd plug in values of t. That'll give you your change in x and your change in y, and you'd plot the points that way. Next up are the parametric equations of a line. We're going to use these a lot more frequently. So the parametric equations, we're going to have an x equals and a y equals. For the x, we're going to take our x point that we know and add our change in x for any given t. For y, we're going to take the y coordinate that we know and add our change in y. Okay, so just like the last one, x1, y1 is our point on the line. And a1, a2 is our direction vector. So let's look at an example. So we have a line that passes through the point 2, -4 with a direction vector of -3, 1. So we're going to do three things with this. First, we're going to find a vector equation. So we're simply just going to plug the given information in. So my vector equation is going to be the point plus t times the vector. Next, we're going to find the parametric equations. So we're going to have x equals and y equals. We're going to have our point, 2 and negative 4. And then here we're going to have minus 3t in the x direction and plus 1t in the y direction. Okay, now we're going to find the slope-intercept form, good old-fashioned slope-intercept form. So the slope, remember, is going to be the change in y over change in x. Okay, which is going to be 1 over negative 3, or negative 1/3. And we have a point, so I'm going to use another form of a line to get slope-intercept. I'm going to use point-slope. And plug in my given information. So we're going to have y plus 4 equals negative 1/3 x minus 2. And then we'll solve for y here. So I'll distribute. So we're going to have plus 2/3. And then I'm going to subtract 4, which would be 12/3. So y is going to equal negative 1/3 x minus 10/3. Okay, we're going to name the direction vector and 2 points on the line, and we're going to write a slope-intercept form of the line. So my direction vector we're going to get from the coefficients of t. So that's going to be a negative 4, positive 1, which means my slope is 1 over negative 4. For the points on the line, we just plug in different values, convenient values. So if I plug in, say, 0, I know a point on the line is 3, 5. And if I plug in, say, 1, we're going to have 3 minus 4, which would be negative 1, and 5 plus 1, which would be 6. Then I can plug this into point slope to find the equation of the line. So we're going to have y, either point, minus 5 equals negative 1/4 x minus 3. Distribute. And then we're going to add 5, which is going to be 20/4. 23/4. Next up, we have an equation of a line. So y equals negative 2/3 x plus 5. We're going to do several things with it. First, we're going to determine slope. So my slope is negative 2/3. Okay. Determine a point on the line. Okay, well, an easy point would be the y-intercept, so that would be the point 0, 5. Next, we're going to find the direction vector. Okay, so the direction vector we're going to get from the slope. So this is the change in y over the change in x. So we're going to have the change in x is 3, change in y is 2, and the negative can go with either of them. It doesn't matter. Next, we're going to write in parametric form. So we've got our point and our direction vector. So we're just going to have x equals y equals. So we're going to have 0 minus 3t and 5 plus 2t. Or these are switched, and you don't necessarily need to write the 0 there. Our final example, we're going to find the parametric equations through the points -5, 6, and 3, -1. So let's come up with our direction vector. So for the x, we're starting at -5 and ending at 3. So we're going +8 in the x direction. And then we're starting at 6 and going to -1. So we're going -7 in the y direction. So then we just have our x equals and our y equals. Either point works. And then we're going +8t in the x and -7t in the y. So those are the parametric equations for lines.